Hello everyone, myself Aninda Bhattacharya, I'm the Executive Director of Celestial Earth. So today I'm going to talk about our latest AI ML enabled model called Spatially Integrated Building Energy Assessment Tool, which is developed by our organization as an open source AI ML powered geospatial tool to support the distribution companies in India to assess their current status of the network and power demand and its hourly profile by appliance use type and by assessing the building footprints of the study area where the satellite by using the satellite images. SPIBEAT is built on an open source platform with full functional flexibility, data transparency, and user adaptability for exclusive use. The SPIBEAT version of the tool is with capability of building level hourly energy demand profiling, including its rooftop area assessment for solar installation capacity. The Pro version of the tool is added with the feature of power network modeling to assess the local network conditions like line and the distribution transformer loading condition by hour, voltage variation, etc. This Pro version is also loaded with unique site suitability assessment module which can help the users to identify the most suitable locations for RE and EV charging station installations. And in addition, given the existing network condition, system demand profile, available infrastructure conditions like road network, buildings, etc. And finally, also considering the demographic condition of the area. In summary, the SPIBEAT and the SPIBEAT Pro is a cutting-edge tool that the Celestial Earth has developed for the distribution companies to use free of charge to manage their network, load research for future planning, and meeting several compliance or regulatory requirements, including solar rooftop programs like solar PM Surya Ghar programs, demand flexibility and responses, and also the resource adequacy. This tool can be broadly used for multiple purposes like assessing the solar rooftop potential in the service areas of the DISCOM. It can also be used for assessing the building by building power demand profiling with disaggregated appliance-wise hourly consumption profile, assessment of storage required at the demand and also at the supply side, and finally the suitable sites identification for installing the solar renewable energy solar installations or even the EV charging station facility with the effects of those installations on the distribution network like line congestions, transformer loading, voltage fluctuations, etc. And finally, it can also be used for cooling demand assessment by building and also energy consumption indexation for the building energy rating purposes. So overall, this is a multi-purpose tool that has been developed in-house by the Celestial Earth with a collaboration with the Central Electricity Authority, and it is open to use by any companies or the users in the coming days. Thank you. So overall, this is a multi-purpose tool that has been developed in-house by the Celestial Earth with a collaboration with the Central Electricity Authority, and it is open to use by any companies or the users in the coming days. Thank you. So overall, this is a multi-purpose tool that has been developed.
Now let me introduce how SPIBEAT tool works. This tool is the integration of 3 different open source tools.
Firstly, building footprint data is collected. In this step,
2D layout of the buildings within the region of interest is extracted. In the next step, we use 3D modeling technique to convert the flat building footprint in 3D form. This step captures essential building geometry like height, volume, and rooftop area. Then in the next step, geospatial shapefiles are created which contains georeference data on building height, floor area, number of floors. Parallelly, weather data is also prepared using climatic modeling tool which simulates present and future climate scenarios including temperature, wind speed, precipitation and more. In the next step, the geospatial data and the weather data are imported into the energy analysis model. This model involves two types of input data. First is the primary data like building geometries, typologies, and weather, and the second is the default parameters such as building envelope, HVAC system, etc. This model then uses these data to generate secondary data like indoor comfort, cooling systems, and the internal loads. The outputs which can be obtained using this SPIBEAT tool includes space cooling demand, total electricity consumption, GHG emission and rooftop solar potential for each building. It can also help in preparing district level thermal network layouts for optimized energy distribution, suggesting efficient building connections.
Let us walk you through how the SPIBEAT Pro version works. It starts with the performance of the distribution network with the real-time data that is being sourced from the CE tool. Further, the tool enables us to create and evaluate different multiple scenarios including RE technologies and EV charging infrastructure integrating to the grid. So let us see how this SPIBEAT Pro comes into action.
It opens with a login page where users sign in using their user ID and password. After logged in, users can build electrical network by uploading the necessary data for substations, feeders, DTs, lines and more, all provided in CSV format. These files can further be customized to reflect different network configurations. Once the relevant files are uploaded, the electrical network can be visualized with all its components accurately mapped to their geographical locations. Next, an optimal load flow analysis is carried out, generating results for key technical parameters such as line loading, DT loading, and voltage, presented both in tabular format and visually mapped onto the network. Now moving forward, along with the technical results, key geographical layers like LULC, LUSN and road network, climatic data such as irradiation and temperature are uploaded to assess site suitability for a chosen area. Finally, the site suitability map tailored to given electrical network is generated. This holistic approach supports smarter planning, improved grid resilience, and a smoother transition towards a sustainable energy future.